All right, so hello everyone. This is week 4 of programming training, and we'll be delving more into writing a better autonomous. And this week's video is actually be probably quite short because when we were doing team programming and with the rest of our team, our curriculum was kind of is a bit much, and our team had some technical difficulties with the robot, fixing that. So the content for this week is a bit on the lower side. So here's a bit blurb of our team again. So this whole training overview will be hosted by Wolf Robotics in a 6-week session, and to cover higher level overview and fundamental technical knowledge of Java and FTC robot programming. So no previous experience is needed, and here we are on week 4 on autonomous continuum. So a week 3 recap on that video, we were introduced to FTC SDK, and we wrote op modes on how to, or really just one op mode on autonomous, and how basically autonomous program with automatic just went through a bunch of instructions, and for us that was just setting up and initializing the robot and then moving forward and turning left. And we also talked a bit about how to connect the robot and down as well. And so actually something that we would like to introduce this week that we probably should have introduced last week as well is our Teleop and autonomous goals. So, and this is just general goals actually for any program that could be helpful. So Teleop, that's taking human input through the gamepad and using different types of buttons to do different actions, and making all those button interactions intuitive and easy so that the driver can drive and do his or her job well. And so Teleop is moving motors and servos based on that input. And there's also this holonomic drive extension, and this is a link to how to create a mechanism drive. This is particularly useful for programming autonomous to control a full drive. You guys can take a look into this. I'll probably be covering this later as well. But things like this neat setting power based off y-axis and the joystick inputs. But moving on, we'll have autonomous. So in autonomous, you can already create a pretty good program by just using encoders, jar, and PID tuning. And so encoders, we're gonna have to probably talk about understanding motor count and counts of, so taking this encoder count and converting it to distance. And then for gyro, that's gonna be using 3-axis rotation, and really only need one, which is the yaw, to see where your robot is headed. And finally, we have PID tuning, where it's able to correct for error, especially in turning well, and being able to turn quickly and accurately. So for the lab, we'll be just talking about driving in a square and improving autonomous. We won't be getting into encoders or gyro, they'll be in the next couple weeks. So if we go ahead and open up our Android Studio, so as you may have remembered, our push ball auto drive by time only moved forward really and turned left. So let's go ahead and write some methods to still only using time, but we'll be able to move forward, sidestep, and overall hopefully move in a generally good square direction. I'll be also improving some parts of our hardware push ball methods as well. So if we go ahead and let's actually first write a method for just moving in a square by moving forward, turning, forward, turning. And so let's go ahead and write a for loop. So we'll do for int I equals 0, I is less than 4, I plus plus, and this will run 4 times. And we're going to go ahead and move forward 4 times, so no turning yet. And so as you can imagine, this would probably just move forward with this forward speed for 5 seconds and wait a second between each interval. Let's make it like 3 seconds actually, so you don't move too far in your field. And then after this, you would probably just run off the field and nothing would really get done. And so let's go ahead and add a turn as well. So we're going to do robot.set powers, and probably should have deleted that. Negative turn speed. So this is turning left, so we'll be starting doing a counterclockwise square. Turn speed, and turn speed. So we want to make sure that our left motors are going backwards, while our right motors are going forward. And then we can go ahead and run time.reset again. And then we can really just copy this over. And then we put this as turning instead. And then maybe you're honestly, and so this is one of the downfalls of time that will be hopefully improved by both encoders and gyro, is the issue with this is when you're turning, how long do you turn for it? You don't really know. And if you maybe had a different robot or had a different build or added weight, or for different systems, this turning is not consistent at all. And even with battery voltage, it does not work when you have low battery versus high battery. And so we're looking to improve that, but for now, we'll just keep this solution of turning. And we'll probably have to play around with this number. How many milliseconds do you take to turn? And then, and it's not going to be exactly accurate either. This uses a lot of guessing. But we'll just go ahead and keep this, and we'll set the motor powers back to 0 and sleep for a second. And so hopefully this is your turn and square method with both moving forward and turning. But there is another method. You guys can test this out, play around the numbers, figure it out. This should be able to make generally decent square. So it won't be great, as we'll see later with encoder and gyro, but it'll make a decent square. And let's also do another method of turning where it's sidestepping. So instead of doing a for loop this time, we're going to go ahead and we'll go ahead and improve our hardware push-bot method. So over here we have set motor powers, right? And if we wanted to do a sidestep turn or sidestep square, driving in a square, we'll probably have to do something like this, right? So we have to move forward. So let's copy our code. We'll have to move forward, and then we're going to also have to wait maybe 3 seconds, move forward, and then we set the power to 0. And then if we do it again, but this time we're going to have to sidestep, let's say, to the left. So maybe we do forward speed. So back to that diagram. Let's see if we can find that diagram on here. Back to that diagram. You can see how if we want to sidestep left, right, we have to move the left wheels in and then the right wheels out. So if we do that over here, so left front in, right front, so left front in, so actually negative forward speed, right front out, so positive forward speed, and then left back forward. So by the way, how I know this is from how we set this up. So left front, left back, right back. So left back also positive, and then right back negative. And so that will make us move in the sidestepping left direction. And so we do that for maybe 3 seconds. We set the power to 0 and save 1,000 seconds. You can see how this is really repetitive. The only thing we're really changing is here. So why don't we improve our hardware pushbot to have a method like that? So let's go ahead and actually just delete this, and we're going to pretend we set up a method, and we're going to actually do it later. Set move by time, and then we're going to go ahead and have a forward speed, right? And we have four forward speeds. So forward speed, and the idea is we can just pass in left front power, right front power, and so on. So it's going to be, and we'll call the set motor powers method inside there. So I'll show you how it's done. So we'll do that, and then so we'll set the powers, and so for each motor, and then we'll go ahead and put in also the runtime. We'll also pass in the runtime, this runtime object we have that we'll be using. And then we'll also be passing in as a Boolean op mode is active. And the reason why we want to keep this, actually what we'll do is pass that in, and we'll also pass in, this. So I'll just go ahead and show why after. But we'll pass in all these, the runtime, this, which refers to this actual op mode, and we should be okay. Oh, and then also obviously time forward. So time. Let's say the time we want to move forward is like 2 seconds. And then we'll go to our robot.move by time, and we'll create a method. Like a move by time. And then we have to have the same parameter. So we'll have these 4. We'll also have the runtime and elapsed time runtime object. And we'll also have the time, the double time, how long you move forward for. And then we're also going to take in an op mode, so linear op mode. Linear op mode. And there we go. Oh, we also want to do public void, so we're not returning. And this is a pretty big method. And we're also going to want to create the same method, but instead of all these, we have an all power option. And so, well, you can probably guess inside this one, we'll just call all power, call the one above. Oh, make sure double all power. And we'll do all power, all power, power, all power, runtime, time, off. And so this method, we'll call this method, which will move the robot at a certain speed for a certain time. And how we'll do this is first, we'll set the motor powers just like we did before. And the forward power, right forward power, left back power, right back power. And so that'll get our robot moving. And then we're going to go ahead and use runtime that we pass in, reset. And then while runtime, let's see. Oh, while the runtime, or actually while, and then the reason why we use this op mode is so we can get the op mode is active. So op mode is active, and the runtime dot milliseconds is less than the double time that we pass in. And then we're just going to go ahead and leave this blank. We actually don't have to do any telemetry. If we wanted to do telemetry, pass in another argument. But I think that's just a bit much. But actually, we'll go ahead, since we didn't do that much this week for our team, we can go ahead and pass in the telemetry object. So actually, I think that's fine. And then we're going to have to take in another method called, or another argument called telemetry. And so we want to pass all this stuff because since this is just a hardware push bot, nothing doesn't extend to op mode or anything. This is where we'd be getting all our stuff to use from. So this one probably want to do telemetry. Passing the telemetry here. Okay, and then we could do something like telemetry dot add data, moving for, then plus, or move by time running. And then we can put something like, we can maybe pass out all the powers. So a left power, and then, or let's say, we can put 4 and then time, and then seconds. So it might be like 3 seconds. And then telemetry dot update. And we can also add some more data. So let's go ahead and do that. So add data, and then we can pass in the LF power, and the value is, guessed it, LF power. And so actually, this is probably something like this put in there, but it's all right. And for RF power, then LB, RF, so LB, RF, and then we'll be able to update, and it'll give you pretty good data. And then after all this, we want to set motor powers to 0. And then we could even do something like op mode dot sleep second. But this is pretty optional. Maybe we should, because you might be wondering why your program's sleeping. So we can go ahead and open up our push bot, and then you can see that this works now. So this will actually be sidestepping. So we first sidestep left, and actually we probably want to move forward first. So so we can go dry or move by time, and then since we have a method for all speeds, we can just do forward speed, runtime, 3. And then we're going to do another one. Move. So move forward, we sidestep left, and then we move backward, negative forward speed, runtime 3, this telemetry, and then finally robot move by time. Then we want to sidestep right, so forward speed, negative forward speed, negative forward speed, runtime 3, this telemetry. Okay, and then you might be wondering where I got this from, and if we just look back on here, or just the opposite of sidestepping. So right wheels are going in now, left wheels are going out. So left front going forward, use that to go out. Right front going in, going backwards. Left back going outwards, going backwards. Right back going forwards to go. And then we can also add a sleep between each of these. So, or let's actually, this is probably a really long method. I don't know if this is really against convention, but we can also add a, so we can change this to have a default value of sleep, right? Well, we can have this sleep. Actually, you know what? Never mind. We'll just keep it simple. But you could probably also add another parameter to this, but that'll make a really long method. So let's just manually do sleep. Then finish off. So sleep for a second between each of those. And you can go ahead and test both of these. So if you want to comment something out, you can just do Control/, so only one of them runs. So this one's moving forward while turning, and this one's just sidestepping. Sidestepping, since you're sidestepping perpendicular, usually it's going to be a more accurate square. But as we learn later, we can use encoders to even make this more accurate. So make same distance every single time, same size as square, at same speed, regardless of any really external conditions. And with gyro making the turning better as well. And then PID tuning is going to be helpful for just the idea of a PID controller will be helpful for things like turning quickly, but also turning accurately. And okay, so that's about it. So the 2 move and square methods. This was actually a very long video, and let's go ahead and head back. So that was basically it. So thank you everyone for attending this week 4 training. Just if you guys have any questions, feel free to contact us at robotics12525@gmail.com. And just keep on learning. If you have any questions, drop in a comment on, or email us, all the same stuff. And thank you. Hopefully see you guys next time on next week 5 programmer training.